Hey guys, welcome back to the continuation of the same topic. I was doing the question number one, rather, I have finished the question number one in the first short video. I have started the question number two. This is page number two, question number 26. Currently, right now in front of you, I have started that question in the last video as well. I'm going to continue this question. It is related to separation and purification again. It is about a sample of rock salt contains sodium chloride and sand. We know this thing already that sodium chloride formula NaCl is soluble in water, whereas sand is formula SiO2 insoluble in water. They can be separated by differential solubility. And what is differential solubility? I have discussed this thing already while teaching you this separation techniques. Differential solubility is that solubility of the two substances differently in the same solvent. For example, just consider solvent water, whereas the two solutes can be either sodium chloride or sand. So sand is insoluble in water, whereas sodium chloride is soluble in water. So they have different type of the solubility in the same solvent. This process is called as differential solubility. Right now you can see this thing that pestle and mortar are used for crushing and grinding. So it is happening in step number one. In step number two, we are going to dissolve this in water with the help of a glass rod, which is acting as a stirrer. And in step number three, we are going to do the filtration. Okay. In the previous video, I have told you that sometimes examiner is just giving the blank to write down the name. Sometimes he is writing the wrong names and then he is asking what is the correction, etc., etc. So this is the question currently in front of me, and I am going to solve that. Right now, they are saying A part is done. It is already mortar. I have told you in the previous video. Currently, it is B part which we are solving right now. Explain why the mixture is heated and stirred in step number two to achieve the maximum solubility, to get the more and more amount of sodium chloride dissolve in it. So I am writing here the answer. What is that? To achieve maximum solubility. To achieve maximum solubility. Okay, to achieve maximum solubility, we have to heat it and we have to stir it. In this way, we can achieve the maximum amount of sodium chloride being dissolved in this. Okay, name the apparatus labeled B. Okay, name the apparatus labeled B. It is called as a filter funnel, which I have already written here. This. Okay, which I have already written here. So you may write this over there. Please, I am telling you again and again, whenever examiner is asking you the question, you are not allowed to write down over there. This I have written only for the explanation. You have to write down your answer over there. Many times the paper is being scanned, and in this way the examiner will not be able to look into this. He has to look into the answers over there only. Okay, so please write down the answers in the given spaces. And what is the C part one? It is called as the filter funnel. Okay, filter funnel. Now the next question, state the scientific term for the sand left on the filter paper in the step number three. So they are talking about this now. It is called as a residue. It is called as a residue. And remember this thing that the one which is passing through the filter paper is called as a filtrate. So filtrate will be collected in the conical flask, whereas the residue will be stay on the filter paper. Okay. Describe what the student must do after step number three to obtain the dry crystals of pure sodium chloride. Now the point is this: the student should shift the filtrate from the conical flask to china dish first of all, and then student should heat the solution to saturation. It is a point when crystals are starting appearing. Okay, start appearing. Okay, so heat the solution to the saturation or to the crystallization point, and then student should filter the crystals, wash the crystals with alcohol, and dry in the layers of the filter paper. As sodium chloride is soluble in water, so student has to wash the crystals with the help of alcohol, not with water. Okay, so please be careful about this as well. I'm going to write down the answer in these four lines, and you need to be very careful about this as well. So I am just minimizing a little bit more. Okay, should should shift should shift the filtrate from conical flask to china dish, and then heat the solution till saturation. Filter the crystals Washed with alcohol, dried in the layers of filter paper. Okay, so this is how we have to write down the answer. This is how we have to reach the destination. Examiner is saying very clearly pure, pure, and dry. Okay, so please be very careful about the answer. Now I'm on the next page, and that is related to the paper chromatography. You can see it from the diagram. It is about the paper chromatography. Remember this thing, the diagram which is made is of paper chromatography. You people may not write the chromatography only. Please be sure that you are writing the complete name, and the paper on which this chromatography is carried out is called as chromatogram. So we have to find out the two errors first. First of all, a student should read down the question right from the beginning. A student investigates dyes contained in different colored inks using chromatography. Water was the solvent. The diagram shows how the student set up the apparatus. Okay, done. Now we can see that apparatus is there. Okay, now the problem is this here. Right now we can see this thing that this solvent level is above, whereas solvent level should be below that baseline. Remember this thing, this is the baseline which is drawn in the ink. Basically the baseline should be drawn in the with the pencil. So there are two mistakes here. Number one is this ink thingy, and the number two is the level of the baseline. The baseline should be above, whereas the depth of the solvent should be below that baseline. Okay, otherwise instead of traveling up, the spots will start dissolving inside the solvent at their places. They will start traveling down, hence the examiner will not give you any mark, because this experiment is not going to give you any result. Okay, so what will be the answer for question number one? Identify two errors in the way the students set up the apparatus. Number one, baseline is in the ink. Baseline is in ink. Only identify. They are not asking the corrections. Okay, and then what about the number two? Baseline should not be immersed in the water or the solvent, or you may say that depth of the solvent is above depth of the uh, depth of the solvent is above the baseline. Above the baseline. So this is an important point. You need to write this as well. Okay. Now the student can then carried out the chromatography correctly. So it means that he has made the corrections. The diagram shows the results. You people may look into the corrections now. Okay, and the diagram. Okay, guys, look at here right now. Can you look at there right now that red is not traveling at all. Red is not converting itself into its spots, and the yellow is converting itself into a single spot. Okay, whereas orange is going to convert itself into two spots, whereas green is converting itself into two spots as well. So here we can check this thing that orange is converting orange is converting itself into two spots, which are matching with, one of the spot is matching with purple and black, whereas the other spot of the orange and yellow and green is matching with that of black only. So we can check the results from this. Okay, whereas blue is also shifting itself into a single spot. Okay, which ink contains the greatest number of the soluble dyes? So it is orange or black or blue or purple. We need to look into it. It is the answer black. Why it is so? Because black is converting itself into three. Okay, greatest number. So we have to write black, and we can say this thing that it is going to convert itself into three soluble dyes. Three soluble dyes. Okay, then what is the next question? Which two inks are made up of single soluble dye? Single soluble dye. We have to mention two inks for this. You can check either yellow, which is converting itself into a single spot. We may check blue as well. It's also converting itself into a single spot. So the answer is yellow and blue. Yellow and blue. Okay. Then from the chromatogram, it is not possible to tell if the red ink contains different dyes. Suggest how the experiment could be changed to find out if the red ink contains different dyes. Okay, guys, it is just letting us know that red dye must not be soluble in water. That's why it is not going to convert itself into its components. To convert it into its components, we have to select the some specific, some different solvent in which this red ink thingy, this red dye thingy, this red spot can be converted into different dyes, different spots further. Okay, if it will be soluble, obviously then it can be converted. Okay, so what we can take right now, we can say this thing that alcohol or ethanol can be taken as a solvent. So what we can say, as red is not soluble in water, so solvent should be changed. Okay, red is insoluble in water, so ethanol can be taken as a solvent. Okay, so this is the explanation related to this question. Guys, now we are done with three questions. One question, the question number one, which I have solved in the previous video, question number two, and question number three. Now we have finished. Now we are on question number one again. Okay, so this is the question number one at the top. This is the question number four. It is on page number four right now. It is a question which is related to the gas collection. You people can check this thing that it is a question which is related to gas collection. The X method is related to those gases which are heavier in their sizes, heavier in their masses, and they are going down. Okay. Whereas this Y method is related to that gas which is heavier in the mass and it is going up. Whereas Z is a method which is telling about those gases which are insoluble in water, so can be collected through water. Okay, let's see. Name the apparatus D. Name the apparatus D here. It is the gas jar here. It is the gas jar in which the gases are being collected. Which two sets of the apparatus X, Y, and Z can be used to collect gas A? Look at the properties of the gas A first of all. Gas A is less denser than air, so it means that it cannot come down. The gas is insoluble in water, so it means that it can be collected through water. Gas A is colorless, so it means that it can be collected through water because the bubbles of the gas can be seen over there. So either Y or Z, because this is a lighter gas, this is less denser. So it is Y and Z are the answers. Okay. So which set of the apparatus Y, Z, or X can be used to collect gas C? Okay. So to collect gas C basically. Okay. So what we can say here, look at the C right now. It is soluble in water, so we cannot collect it through Z method because it is soluble. So more denser, more denser. So it will move up or move down. It will move down. Okay, so that's why we can write down the answer is X, because it is more denser to collect gas C. So the gas C is more denser, so it will come down. It is soluble, so we can never collect the soluble gases through water. Why it is so? Because soluble gases will react with water. As a result, the gas will be wasted. Okay. Now we can come on the D part one. State why apparatus Y is less suitable than apparatus X to collect B. Okay, look at the B first of all. About B, they are saying this thing that it is more denser than air and it is insoluble. Okay, so what we can say here, they are saying that apparatus Y is less suitable. Okay, than apparatus X. So apparatus X, they are considering it is more suitable to collect B. Okay, let's see, as compared to apparatus Y. Okay, so to collect gas B. Okay, so apparatus Y is just taking the gas up. So if it is more denser, then how it is going to move up? So that's why X will be used. Okay, so what is the answer? As B is a denser gas, so cannot be collected through X. Okay, so what I am writing here, as B is a denser gas, as B is a denser gas. Okay, state why apparatus X is less suitable than apparatus Z to collect gas B. Apparatus X is less suitable, apparatus X is less suitable than apparatus Z to collect gas B. As gas B is colorless, its bubbles can be seen in water. Okay, so you can see this thing that as gas B is colorless, so its bubbles can be seen in water. That's why this Z is better. Okay, so I'm writing here, as gas B is colorless, its bubbles its bubbles can be seen in water. Okay, guys, can you look at the Z right now? You people must have seen this thing that bubbles of the gas are very clear in water. And this is a daily example which we are observing in all the fizzy drinks. The bubbles of the carbon dioxide gas can be seen in 7 Up. 7 Up is a fizzy drink, a regular example of our life, and it is a colorless liquid. Whereas the bubbling can be observed through those fizzy drinks as well. Okay, I'm deliberately not giving you the example of Pepsi or Coke in which it is already colored. Okay, so currently I'm on the next question, which is related to the question of condensation and what is happening in this question. Let's explain this and let's look into the fact that what examiner wants from you in this question. Okay. Okay, so it is a question in which a bung is there. Bung is basically a stopper. Ethanol can be oxidized. Let me zoom it a little bit more. Okay. So it is ethanol can be oxidized to ethanoic acid using acidified aqueous potassium manganate. In the apparatus shown, there are two errors in this diagram. Guys, look at here right now. First of all, there must be a stopper or a bung. Otherwise, instead of moving up, the fractions may go out as well. Okay. Then there must not be a bung at the top. Why it is so? Because if the bung will be there at the top as at the top of this whole condenser as well, how the fraction can go out of the condenser. Okay, so there must be an outlet for the condenser. If the condenser is closed from every end, how the fractions can go out. Okay, so first of all, add labels to the diagrams to show where water goes into and out of the apparatus A. Okay, remember this thing that at the bottom part it is the water inlet. Okay, so what we have to write it is cold water inlet. It is not water inlet, it is cold water inlet. And what about the other one? It is the water outlet, because all the coldness of the water is shifted to the condenser. So cold water inlet, and we can check this thing that it is called as the condenser. It is called as a condenser, whereas this is called as a water outlet. Okay, so these are the points which you need to keep in your mind. Water outlet. Okay, so we have just written the add labels to the diagram show where water goes in and out of the apparatus A. State the two errors I have told you, that there must be a bung in the mixture plug so that the fractions may not go out, whereas there should not be a bung at the top so that the fractions may come out of the condenser. So please be careful about that. Let me write this. There should not be a bung at the top. Should not be a bung at the top of condenser, so that fractions may come out. And what about the number two? There should not be a bung at there should not be a bung at the top of the condenser. This is just the point which we have written. And what can be the other point? There should be a condenser at the receiver flask. Okay, should be a mixture flask. Okay, should be a bung with mixture flask so that content may not be removed from the mixture flask. Heating with apparatus A in the vertical position is known as a heating under reflux. Name the apparatus A. It is called as condenser. It is called as condenser. Why is this apparatus is in the vertical position? Remember this thing, guys. A condenser can be like this or can be like this. The A condenser is basically for the reason so that the unreacted content may be sent back, whereas the B condenser is for the reason so that the fractions may be shifted, basically so that the fractions may change themselves from the from the gaseous fractions to the liquid state. Okay, so that this is the basic concept for the condenser. A, I'm repeating my words. A is for the reason so that the unreacted can be sent back to the mixture flask, whereas B is for the reason so that the fractions can be shifted from the vapors to the liquid state. So there are two types of the condenser. So I have told you about the use. Now I'm writing it so that the unreacted reactants may sent back to send back to send back the unreacted reactant. Okay, so this was the detail about this question. Now come to this question now. It is related to collection, measurement of a gas in a chemical reaction where a reaction is happening between calcium carbonate and hydrochloric acid. You can check this thing that as a result of calcium carbonate reacting with hydrochloric acid, the gas produces carbon dioxide, which will be measured by this gas syringe. Okay, you can check this carbon dioxide thingy. And what is A? A is called as a conical flask. A is called conical flask. Whereas what about B? B is called as gas syringe. Okay. Gas syringe. Okay. And guys, there is a piston in that gas syringe as well. In each experiment, the student adds dilute hydrochloric acid to an excess of calcium carbonate. The volume of the carbon dioxide is in B is recorded after every 30 seconds. Okay. So what is meant by the excess of the calcium carbonate? It means that all the reactant calcium carbonate has reacted with all available hydrochloric acid. It means that unreacted calcium carbonate will be left at the reaction, at the end of the reaction. Okay. Excess of calcium carbonate, it means that unreacted calcium carbonate is left at the end of reaction. Okay, name the two pieces of the apparatus A and B. What about A? A is the conical flask we have just discussed. A is conical flask. Okay, what about B? Name the two pieces of the apparatus. Look at the B. B is the gas syringe. Okay, we have to write down the name only. Gas syringe. Okay, so I'm right now the currently last part of this video. The student does experiment number 1 at 20 degrees Celsius. Name a piece of the apparatus used that is used to keep the temperature constant. So it is an electric heater with a thermostat. Basically, thermostat is used to control the temperature. Each thermostat can keep the whole setup at one temperature. You may add a thermometer as well because we are measuring the temperature as well. So electric heater with the thermostat. Heater with thermostat. All right. So this was the whole thing, whole information about this 5, 6, and some questions are solved here. Okay. Let me come to this as well, inshallah. In the next video, I'm going to explain this question. Okay. All right. All right. So please, guys, we have discussed few of the questions related to separation and purification, few of the questions related to kinetic particle theory as well. And I have just kept few more questions for you related to these topics so that you people may have a better preparation. But it is always important to practice the past papers. If you people are finding any query or a question or demanding any specific question, you may send me the question in the comments. Thank you very much, guys. Take care of yourselves. See you in the next class, inshallah.